Hello, welcome back. We're going to do some more programming. So I recorded a bunch of episodes, but I don't like the direction they were going, so I didn't upload them. I tried my hand at I don't want projects. That's my work projects. Holy cow. So last time we left, I was trying to implement combat, and I needed to build the game engine that actually fights the combat. And
in the combat, like an AI.
Well, no, it's the rules. Execute the rules of combat. Like if somebody does something, what happens?
Dad, what are the numbers for?
Yeah. What are the numbers for? Where?
Under the screen.
Oh, that's an i3 feature. You can flip back and forth between different desktops. This is a feature that Mac and Windows don't have, that pretty much every Linux distribution, every Linux Windows environment does have, is you can create different desktops and flip between them rather quickly. So that's what I can do. And if I want to create more, I just, I can just create whatever number I want. I can send windows to different desktops. This is a tiling window manager, of course, so we get all those, the goodness. So let's say I wanted to start a new desktop with Qt Designer on it. So I go over there, hit that D, and then I go Designer, Qt5. See, it pops right up right there. It takes a little bit because it has to swap in.
Water.
There it goes. Anyway, I'm not going to be doing much Qt though. I'm going to be doing actual programming. So,
how do you exit out of the desktop? How do you delete a desktop?
You just get rid of all the windows. It disappears. i3 just deletes desktops. With KDE and GNOME, I think you have to say like, oh, I want 5 desktops, or I want 4 desktops, right? And you have to create and destroy desktops manually. With i3, you just go to the desktop, So
like the computer over there, it's just you have to create the desktops,
Yeah.
or you could go to i3.
Yeah, there's a way to switch this to be borderless. I kind of want to do borderless windows. Let me see if I can. I'm gonna look it up really quick in i3 here. Nope, nothing in there. Let's go. It's really quick. That's what I'm using here. I guess Yahoo, right? There's a way to switch it to borderless. No, I don't want to do that. Border style for new windows. I think that's what I want. Come on, mouse. Come on. There you go. Ooh. This option determines which border style new windows will have. The default is normal. Note that new float applies only to windows which are starting out as floating windows. Dialog windows. How do you change?
Adding vertical borders or something.
Yeah.
And how did the search bar pop up there? On top of the desktops.
Yeah. There's a way that you should be able to turn. Huh. Let's scroll up some more. Is there a border toggle? Last findings. Let's see. Blah blah blah.
Dad,
Yes.
I was able to swallow water, which in my mouth this big.
Mm-hmm.
It was this big.
Wow, that's a lot of water. Oh, here we go. Come on, something in here. Oh shoot, it doesn't like that.
They're a little too.
Does not like that. Yeah, I really don't like the borders. I want to turn them off, but they're not that big of a deal. Besides, it probably helps you guys get some context here. So let's just ignore that for now. Maybe I'll figure it out one day. Right now, I don't want to. I want to program. So, I have. Let's see. My blah blah blah. 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 Blah b basically figured out what I'm going to do. I'm not going to be using async IO. I don't need it. The biggest issue that I ran into, and I tried to write this down in the documentation. Let me go ahead and open up the documentation here. I think it's called this, asynchronous RST. Blah, blah, blah. Blah, blah, blah. Yeah, so the save load feature needs something to put on a disk and to read from a disk. And unfortunately, if you're going to save and load a continuation, that's not going to work. I'm sure that somebody will figure out a way to do that one day, but right now that's not the way it works. And, typo. Keying behavior off of events can be difficult unless we build a state machine to handle all the different kinds of events that may affect the behavior. So the issue you run into here is, like, let's say you have a quest, right? And there's like 6 different things you can do to get to the next phase of the quest. If you're going to write that in straight code, you basically say, you have to say, like, if this or that or that or that or that, right? And it gets really complicated really quick. Whereas if you built it as a state machine where you had different events bind to something that says move to the next phase when this event is complete, you can add as many events as you want. You don't have to change the code. You just need to keep adding stuff. And that's, if you build a system like that where you add states or you add transitions, then you can extend it as far as you want to go. It does get more complicated because you have so many states, and it becomes more and more difficult to predict how the different states will interact with each other. But it's pleasant because the states can be added to, So the problem that people run into with state machines is they build this really complicated thing really fast and they lose track of how it all works. And part of the solution is just being better at tracking your complexity of your program, documenting, drawing pictures and things like that to keep yourself on the straight and narrow. But really, the reason why there's certain styles of programming that lets you build really complicated things really quickly. And it's not always the fault of that programming style. Like, a different programming style won't give you a better result. Other programming styles might just make it much harder to do anything. Get rid of that cup. I don't want to make that noise. Other programming systems or other programming ways of programming might give you, it's hard to explain, but it will give you, let me try this one more time. Okay, you use a certain programming style and you end up with a really complicated program.
Different styles give you different results, right?
I'll finish the thought here, okay? So use a different style of programming and you don't get a complex result as quickly, right? Now, that could mean one of two things. It could mean, one, it just takes longer to get stuff done in that second programming style than in the first programming style. Or two, it could mean that the second programming style allows you to create more complicated things without building a complex system. Okay? So you really can't tell which way it is. State machines are basically the simplest programming style that you can imagine. It's even simpler than a recipe style. And with state machines, people quickly build complex systems, right? And it can be complicated. It isn't because state machines themselves are bad. It's because people tend to be sloppy when they build state machines, and they tend to not be clear on how everything works. But in the end, every program is a state machine. So you really have to understand state machines anyway. It's just when you program in a different style, you're really saying, I'm not going to use these things that you can do in state machines. I'm not going to use those. I'm only going to use like a certain path. So we're going with state machines. And basically the only entry points that I can imagine. Number one, when the user declares an action. Okay? So they say like, oh, we're going to go north. Okay? Then something's going to happen. There's going to be a response to that event, and the state's going to change based on what they say. Okay? The other case where you're going to have to start running code in the state machine is when you click on the clock to advance it to the next turn or the next round or whatever you want to do. Okay? Those are the only two cases. Normally when you build a state machine, like for instance, if I was building a web server that has a state machine at its heart, I would have to write the code so it responds to the events of, hey, there's incoming network traffic, hey, you can write to an outgoing network socket, or something happens with the timer. Okay? And that's pretty complicated to get that right, to make everything work together well. But here we have a much simpler system where there's limited ways to input and change the state and limited things we have to respond to. So this game class, and I'm sorry my explanations aren't very good. This game class is what, if you go back to my first videos, I had this idea of a universe. Well, this is basically the universe. It's a game. But rather than being focused on containing everything, this is focused on actually running the game. So there's a bunch of methods in here that just run the game. Okay? And my idea is that the game, like if you want to change the game, you will change this class by adding methods or modifying methods. That's how you're going to make your changes. So some of these methods are methods that are intended to be called from outside of the state machine. Some of these methods are intended to be called from within the execution of a state machine, of a response to a state in the state to an event in the state machine. Others manage the event stack, and others are intended to handle the phases. Okay, so I think I got basically a rough model here. I'll just walk through the different functions. So here we have the constructor up on top. Remember in Python, double underscore init is always a constructor. It doesn't take any parameters. It is a Q object, so we do have to call its, the superclass's init method to get it properly initialized. It has a current time. One of the things that I wanted to avoid is allowing people to modify the current time beyond advancing the clock. Okay, there's going to be problems if they go into the game and say the time is now yesterday. Okay, while it makes great fantasy to do time travel, there's going to be problems because if, like, let's say your party's in combat and they're waiting for the 6 seconds to pass for the next phase of combat, and you say, well, guess what, it's now yesterday. They're going to basically frozen in time. Okay, so going backwards in time is going to be a lot more complicated than just saying, like, hey, it's yesterday. The event queue is a priority, a heap queue. It's a priority queue. I'll show you how I implemented that. I kind of adapted the code from the Python documentation. And the event count, this is a counter. So if you go over here and look at what they did for heap queue, for the priority queue, they wanted a way to make sure that the order you added the tasks to the priority queue will be the order they're pulled off if the priority is the same, right? So they had the second sorting parameter called count. And count comes from this JGRPGTools count. This is a generator. Storing generators to disk is not easy. Okay, it can be done. So I said, you know what? Skip the generator. We're just going to have a number, and every time we get the next one, we're just going to increment it. That's basically what the generator does anyway. The generator is kind of nice because it's clean. This way is nice because I know how to store and retrieve it. Okay. I don't have the store and retrieve methods implemented yet, but you can see that so far all of these things are pretty standard. This is going to be a list of things, this event queue. This is just a number. Okay. Properties. Okay. In Python, there's this thing called descriptors. Okay. Normally when you approach this topic, people say descriptors have these get methods, set methods, and whatever methods. Ignore that for now. Okay. There is a way in Python to override the standard behavior. Okay, so what I'm talking about. Okay, so let's say I create a new class called A. Okay, and there's class A. Does class A have a parameter called foo? No, it doesn't. It says attribute error. No, the type object has no attribute foo. Well, let's set foo to be 7. Okay, let's make an instance of A, and sure enough, a.foo is 7. Okay, what it's doing is it's going to the class. Python first asks the A object, not the capital A class. I should use different names. It says, hey, do you have an attribute named foo? And so it looks inside A at all the different attributes it has, and it says, no. Well, it does have foo, actually. That's kind of weird. I guess this is Python 3 behavior. But let's do a.__ dict. This is the dictionary that contains the attributes. It does not have an attribute named foo. However, it does have a class. There's A's class, and that class is a dict proxy. It has something called foo right there. Okay, you see that? So it's actually retrieving from the a class. So if I say a.foo is now equal to 8, so now the class's foo method is 8. Well, sure enough, a's foo is 8 as well. Now, if I add a method to the a object called bar, let's call this one 10. A.bar is 10. There is no such method or attribute on capital A, the class of the object. Okay, you can see that. Now, if I say a.bar is now equal to 11, sure enough, it goes up to 11. Okay, there's two things going on here. This action right here, where you say something dot something equals something, that's the assignment, or you called set. Okay, and the other action here is when you retrieve it. This is called get. Okay, so if I say a.bar times 7, in Python that says first retrieve whatever the bar is of a, and then multiply whatever that is by 7. Okay, whereas if I say a.bar equals 101, 1001, let's say, and then I do times 7, it gives me 7007. Okay, so descriptors allow you to override how those attributes are retrieved. It allows you to basically, instead of having bar be like an actual integer, it could be this weird object with these weird methods. And when you go to retrieve that attribute, it does something weird and returns that instead. And when you go to set it, it does something else weird and does that instead. So this at property says, hey, I'm going to have an attribute called current time, but it's not an actual attribute. It's this weird descriptor thing. And when you go to retrieve the current time, call this method instead and return self underscore current time. The underscore in the front there says this is a private attribute. You shouldn't modify unless you really know what you're doing. This right here says, hey, for the current time setter, and you have to use the same method name here, otherwise it kind of screws everything up. I'm going to convert the time to an integer. And later on, when I have a more complicated time object, I'll be using whatever that is instead of an integer. I'm going to check that the time you're trying to set it to is less than or equal to. If it's less than or equal to the current time, I just return. You can't do that. I probably should raise a value error if it's less than. But I just, I will. I should, because you shouldn't ever do that.
Well, then why are you doing it?
You shouldn't. It happens. Sometimes your code is broken and it doesn't do things right. So raise value error cannot travel backwards in time.
But if you
I'll just do
could
that.
travel backwards in time, if you could somehow like program it to do that, so you'd be able to, wouldn't that mean that you'd also have to, like, you'd have to store all the, you basically have to save every single thing that happened and like put it on a timeline, right? So if you wanted to like go back in time, you go to that time,
So
and then you have to like,
in
store it to
real life physics, we have this thing called causality. Okay, and you can build causal loops. Let me explain. So the idea is that something over here causes something over there to happen. Okay, now let's say something over here causes something over there to happen, and that something over there is warped back in time and causes that initial thing not to happen. So basically you've created this contradictory loop. This is called the grandfather paradox.
Oh, the thing where you go back in time and kill your grandfather before he has a son.
Yes. Now, lots of different stories have approached this problem, and oftentimes one resolution is that the universe rewrites itself to somehow compensate for the new timeline.
If you kill your grandfather, then you never exist. So how
You didn't kill your grandfather. Yeah. So it's a
But
paradox.
then again, where's your grandfather?
Yeah, it's a paradox. So that's one of the problems with time travel. There's a variety of solutions they have. One of the cheesier solutions, I think, is they say, well, you didn't really kill your grandfather. You thought he was your grandfather, but he really wasn't your grandfather. So I think that's kind of cheesy, but that's a way out. One way that I thought of is basically like there's different time possibilities, and all you've done is basically moved yourself to a different timeline. And so one
so
timeline is actually
so it's like
interacting
there's like
with
a,
another.
there's
so it
like-
kind of goes like this: that there's a single timeline, and once you go back in time and kill your grandfather, then it branches off into two timelines.
Yeah, and
Do
so
you
now,
know- do you know
now
what-
all you've really done is move yourself to a timeline where you didn't exist. So all you've done is really travel to a different time. That's
And then you
Anyway.
can
Do
travel
you know what would be
back
really
to
fun?
the original timeline.
What if you, there
the
was
point. The point I'm trying to say here is that allowing yourself to change the time of the clock will have implications for this program. People don't expect that to happen. Okay? It's a nice idea, but it's going to be very complicated to get right. I'm not going to program it in from the beginning. One day, maybe somebody will get smart and say, hey, let's build a time travel feature. Okay, fine, go ahead.
If someone actually wants a time travel
Yeah.
feature.
Anyway, the heart is here. If the time is the same as the current time, it does nothing. It just returns. Otherwise, it sets the time to the new current time, and it emits this signal saying, hey, the time has changed. Okay, so where did that come from? That's a class object. It's a PyQt signal. Okay. All right, so that's how the time works. So when you set the current time or when you check the current time, you're actually calling functions, which slows it down quite a bit, but it's going to give us the kind of protection we need. Okay, add event. This is what you do to add an event to the event queue. You basically say, give it a time, and you add the event. And what this does is it increments the event count so that we have this uniqueness and the order, and it pushes the event onto the queue. Okay. Tick. When the user is in the interface and he clicks to advance the clock, next turn or whatever, okay, then he calls tick, and he passes in an interval, which is how many seconds or whatever to tick the clock. And so we time box the interval so it can't be negative. We also make it to an integer. 0 is an integer. Okay.
I had an idea for battle. You know how each turn is 6 seconds long?
Yeah.
So like you give each player like 30 seconds to play their action, and then like when it's on their turn, then you start a clock.
Sure.
And so it's like 6 seconds long. And then like when the player stops her action, then you stop the clock, and then you say advance to the next clock.
So basically you're saying like you have this much time to make a decision, otherwise it's going to happen anyway.
Yeah.
That's fine. Okay.
Well, I
So-
think it's a little too fast.
Then I introduce this variable destination time, which is the time we're trying to get to. And I say that's the current time plus the interval. I have this while loop that says as long as there's events in the queue and the first event is less than or equal to the dust time. So when I push this thing onto I push into it a tuple here where the first thing is the time the event's supposed to execute, and the next thing is the event count. You know what? I don't need to do max here. I can just... No, I'm going to do max. You can't go backwards. You can't say this event has to occur before that one that's already set to occur. Okay, there we go. And then it updates the time, which will signal, cause an emit. Who would listen to that signal when it's being emit? Well, if you have like an actual like clock thing, a widget, every time the time is updated, it should update that time. So when you emit that, it'll do a bloop and change it, whatever. And then you call the event. The event is a callable. Okay? Let me show you what an event looks like down here. I just wrote a stupid wrapper around. You pass in a function. There's a canceled option. You can cancel it. Canceling does not remove it from the queue. It just says, hey, it's canceled. If you call it and it's canceled, it is nothing. Otherwise, it calls the function. Okay? It doesn't return anything because there's nothing to do with the result. Okay, so here we go. There's the event queue. Tick, add event. Wait, I have tick added twice. No, add event, tick. Okay, ask. Ask is the method where you ask users questions and await their answers. And I have the board filled out with notes about how this could actually work. And I've accounted for basically all the use cases I can foresee. The most complicated use case being, well, two complicated use cases. One is like you ask a question, they give an answer, and then you have to ask a follow-up question. This could be something as simple as I want to attack. And it says, who do you want to attack? Okay. The other option is that something happens in the game. Okay. So let's say you're a wizard and you have a spell to cancel an attack spell that's targeted towards you. Well, if somebody targets a spell towards you, you have to make a decision whether to cancel it or not.
Dad, one more thing. I have an idea about spells. What if, like, you know, in D&D they have the spell slots, right?
Yeah. Yeah.
Well, what if instead of spell slots, like, each spell had their own MP? Like, it uses up a certain amount of magic points.
Sure.
Except you can only get certain spells at certain levels.
Sure.
So you can cast, like, one spell several times.
These are great ideas. But Eliana, you have to understand right now, I'm trying to build the basis of this entire system.
I know.
So whether or not we go that way or some other way, it's not going to change anything about this code here. So how does ask work? Well, it has this onAnswer inner function. This is going to confuse some people that don't know how this actually works. This blew my mind because I came from a C++ C background. Basically, an inner function is a function defined inside the namespace of another function. Okay, so when I say questions here, I'm really talking about the questions of the invocation that created this function. It's not terribly complicated if you think about what it means to say def in Python. Okay, and basically I say, hey, on answer, and show the questions. I have to rewrite this according to what the board says because I had to consider what happens if you save the game and load it. Okay?
Yeah, the saving is not working.
If you save the game and load it, it should show the questions that were in there at the time against the players, right? All right, start combat. This is one of those things that you can call from within an event or you can call from outside, and basically it says this group and that group are now fighting with each other.
Dad,
Yes?
one more thing. I think this might be important. Like, you can only start a combat if an enemy is near.
I have that right here. You want to see the code? Okay.
Or in range of any weapon.
So this first thing here is I say basically I build a comprehension saying give me all the objects in this group of A and B that has fighting true. So if anything's in that group, we have a problem. And here it's going to list which one is already fighting. Here we check to make sure their area is the same. If A.area is not B.area, if they are not looking at the same area, then we have a problem. They can't fight. Then we set A is fighting B and B is fighting A. And then we add an event.
What if you could like join a fight?
No,
Why?
I'm not going to allow that yet.
Okay. So what are you trying to build right now?
A very simple combat machine.
Okay. So joining fights is
Like, I hit
hard.
him, then you hit him.
Yeah.
I hit.
I'm just going to get the basis going, and then we can start adding modifications. Things like joining fights, you know, all that kind of stuff. Then I add an event. When you start combat, I add an event, and I say, I want this to start at time 0, which means right now. Okay? And it's an event with a partial that says, call self-combat decision phase start with A and B. Okay, partial. Partial is one of these cool functions that exists in Lisp and Lisp-like languages that C++, C, and Java programmers are completely ignorant of. And then when they realize it exists, they're like, oh, I could have used that. Okay. So the way partial works is, like, let's say you have a function that takes 3 parameters. Okay. And you know what the first 2 parameters are, but you don't know what the last parameter is going to be. You'd like to create a new function that only takes 1 parameter and then calls the other function with those first 2 parameters set and the third parameter set to the parameter that was passed in. That's exactly what partial does. Now, additionally, let's say you call partial and you provide all the parameters. What you've done is created a function that when you call it, will call the function with those parameters, right? So basically with this partial thing, I'm saying like, I would like to call this function in the future with these parameters. Bam.
Like reaction, basically.
Saying, like, yeah, hey, in the future call combat decision phase start with A and B. That's what I'm saying. So that's basically what partial is saying. Another way to do this is with lambda, but I think partial is better. I think it's just clearer. Okay. All right. So combat decision phase start. So when that event fires, there's a little assertion here just to make sure. I kind of don't like to use assertions, but I just, you know, I threw it in there anyway. It's going to ask for combat options for each of the characters in the group. So a whole bunch of questions will be generated and shown that have to be answered. Okay? And then I have another partial here that says, hey, when you're ready, call combat resolution phase with the first 2 parameters of A and B, and the third parameter will be the answers to those questions. So here we see that, combat resolution phase. It's going to be called with A and B and the answers to those decisions they made. Okay? And then I basically have a loop here. It's going to be calling itself again. It's going to be calling itself again if all the decisions are made, then we implement all the, so basically the decision is going to return an effect or set of effects and options, more questions. If there's more questions, then we have to ask those questions. And so we asked it here. So basically it's going to be self.combat resolution phase with A, comma B, and I don't know what to do for that right now. I don't know how to handle that. No, A, B, and I think I go all effects. This is probably not going to work. Equals all effects. And then we're going to pass in the more options. If I can type, it will work. I just need one. Okay, so it's going to ask when it's ready. It's going to call that and more options. Okay.
How are you gonna test this?
This is going to be extend. Oh no, these will be sets. Ah, shoot. I'll have to fix this later. Okay. And then otherwise, if we don't have any more options, then we're all done. We can go to the resolution phase. But that'll happen 6 seconds later. So self current time plus 6, and then it's going to call self combat application phase with A, B, and all effects. And down here is the combat effects phase, and then we're done. And we're going to add an event to go back to the decision phase start if combat should continue. If combat's done, then combat's done. That's basically how combat can work in this system.
So I have a question.
Yes.
So are you gonna set up like a text thing? You know, like you've seen the game A Dark Room, right?
Yeah.
You know how it's like you click a button, right, and it says something right here, like something happens, like
Yeah.
gather wood, and it's like you gathered 5 pieces of dry wood or something, right?
Yeah.
So you're gonna set it up to like you have to type a command in, like go this far, like move forward 5 meters or something like that, right? You have to do it that way. Or are you gonna have like a button or something?
Yeah, I mean, when you have a question, we've already demonstrated this in a previous video. We had a little test thing where it would generate questions with continuations and such that it would show in the UI the questions, and you answer the questions, and it would run code based on the answers to those questions you provided. So we already have that, you know.
So you kind of like create an effect.
Yeah.
So they give you a cause, and you just you choose the effect.
Yeah.
Okay.
Yeah. Anyway, there we go. That's pretty much. Yeah, that's pretty much how this thing is going to work. I have to work on this some more to get it to actually run, and then set it up and hook it up to the front end. But this is a kind of a high-level view of how to put things together. You kind of saw into my brain a little bit about what I'm thinking right now. So anyway, I hope this was useful. Take care. Goodbye.